Hi dear student, welcome to Maths Academy. I am Azad Ahmad Khan, your mathematics mentor. So today we are going to discuss inverse function property from a definite integrations. Okay. In this session, we will going to cover about the property. What is exactly we are going to study the property. Second, the proof of that property, and we will try to solve few solved example based on this property. Okay. So let's move to first part of this session is about this property. Okay, if there is a function y is equal to fx which is continuous in interval a to b and its inverse is also continuous from f of a to f of b, then there is a relation exists between function and its inverse like this one. If you integrate the function f of x dx from a to b plus inverse of f of x dx from f of a to f of b, that will be equal to b times f of b minus a times f of a. Okay, so this is the statement of the property. You need to remember this property if you are going to solve difficult problem based on this. Okay, the condition of this property is function must be continuous and its inverse must be well defined and continuous in given interval. Okay, let's move to the second part of this session is proof of this property. So as you know, proof of any concept, any property is very important part, because if you directly remember this property, maybe you can solve the problems, but if you know the proof of this property, then you definitely solve any problem based on this property, because you can get some insight about this property, how this property comes from in this say, right? So in order to prove this property, I will going to cover it's geometrically, how to prove it geometrically rather than in form of other calculations. So let's take a coordinate system x comma y. Okay, and there is a general function y is equal to fx. This is the general function. Okay, and as you can see, the first part of this property, this one, this is represent area between x-axis to this function from x is equal to a to x is equal to b. It's mean if we label this one x is equal to a and this is the x is equal to b, this area represent integrations of this one, right? Okay, let's focus on second part, this one. If you are going to find the area of this function with respect to y-axis, then what will be the coordinate of this one on y-axis? That will be f of a, and the coordinate of y-axis at x is equal to b, that will be y of f of b. If you are going to integrate this region from f of a to f of b, that will be equal to what? Simple. This is the elemental width dy and height will be the x. Area represent x dy from f of a to f of b. Agree? Okay. Let's write x in terms of y. Then original function was y is equal to f of x. Let's convert x is equal to in f inverse y. Then f of x is equal to y. Okay. And this replace x in place of y. That will be equal to y is equal to f inverse x, f of inverse x. Okay, so just rewrite this one as a sum of f of a to f of b to f inverse x dx. Let's focus on this result. You can observe this. This is nothing but b times f of b, means this is the width of b and this is the height of f of b. This represents area of this rectangle, right? This one, area of this rectangles, this one, okay? And a times f of b represent area of this rectangles, this one, right? Then you can clearly find the area of this region. Region is this one, this region, total minus initial. This will be equal to b times f of b minus a times f of a. Then the concept is we are going to equate the sum of area in form of integrals into form of product of the length, right? This area, this integral represent area of this region, and this integral represent area of this region, okay? And this represent the area of whole rectangle, and this represent the area of a smaller rectangle, and the minus of this one represent this one, area of this region. So this is the proof of this property. I hope you understand the proof of this property. Okay. Based on this property, let's try to solve two basic problems in this. Before going to start to solve these questions, I would like to inform, if you are going to try to solve this problem without using this property, it might be difficult for you to find the final answer. But using this property, it will be very helpful to you to find this answer. Okay, so let's recall what is our property. A to b f of x dx plus f of a to f of b f inverse x dx, that will be equal to b times f of b minus a times f of a. Okay, this is our property. The objective is you need to identify the main function and its inverse. If this represent the main function and this represent if inverse of this function, then we can say we are in position to apply this property for this question. Let's take f of x is equal to log of a base a x plus under root x square plus 1. Okay, the objective is we need to find the inverse of this function. The process is simple. To find the inverse of this function, let's assume log of a base a x plus under root x square plus 1 as a y. Take antilog, that will be equal to x plus x square plus 1 under root is equal to a to the power y. Okay, let's transfer x in right hand side. Under root x square plus 1, that will equal to a to the power y minus x. Okay, squaring on both side, then we get x square plus 1 is equal to a to the power 2y plus x square minus 2 times x a to the power y. Okay, x square and x square will be cancelled out, and you can find the value of, let's multiply both side by a to the power minus y. A to the power minus y, this will be a to the power y minus 2 times x, that will be equal to 1. From this you can find x is equal to a to the power y minus a to the power minus y divided by 2. Just replace x by y, and that will be represent inverse of original function, a to the power x minus a to the power minus x divided by 2. Then you can clearly see this is nothing but our integrand of the second function, second integration, right? And our tasks remain what? Just we need to find the value of the function at x is equal to 0 and at x is equal to 2. Where, because the limit of initial function is 0 to 2, and let's find the value of f of 0, that will be equal to log a 0 plus under root 0 plus 1, that will be equal to log 1, that will be equal to 0. Okay, log value of the function at x is equal to 2 will be log base a, that will be equal to 2 plus under root 4 plus 1. Then we can simplify this one, log base a 2 plus under root 5. This is the original. Okay, so now we are in positions, we can set this whole integration in form of this one. The rest thing is what? In order to find the answer of the question, this question, you need to multiply upper limit with upper limit of the second integrations minus lower limit with the lower limit of the second integration. This is nothing but 2 times log a base a log base a 2 plus under root 5 minus 0. This is the final answer, and you can get option A is correct. This is a very good way you can solve this problem. Okay, let's move to second one. Again, you need to find where you can apply property in this question. The process will be remain same. Let's write the initial property, that will be a to b f of x dx plus f of a to f of b f inverse x dx is equal to b times f of b minus a times f of a. This is the original property. We are going to apply this property to solve these questions. The objective remain again same. We need to identify f of x. Suppose f of x is log x square plus 3x plus 1. Let's find the value of function at x is equal to 1. This will be equal to log 1 plus 3 plus 1, that will be equal to log 2. Okay, and find the value of function at x is equal to 3, log 9 plus 9 plus 1, that will be equal to log 19. Okay, we can find the inverse of this function by assuming log x square plus 3x plus 1 is equal to y. Let's take antilog on both sides. X square plus 3x plus 1 is equal to e to the power y. Okay, let's solve this quadratics in form of x square plus 3x plus 1 minus e to the power y is equal to 0. Okay, the solution of this quadratic, x is equal to minus b plus minus under root b square is nothing but 9 minus 4ac 1 minus e to the power y divided by 2. X is equal to minus 3 plus minus under root 9 minus 4 plus 4 e to the power y divided by 2. X is equal to what? This is minus 3 plus minus under root 5 plus 4 into e to the power y divided by 2. Okay, Now you can say that we need to integrate this function from 1 to 3. Then you can say just ignore the negative part of this function, because this is not coming to domain of this integration. That will be equal to f of inverse x is equal to minus 3 plus under root 5 plus 4 e to the power y divided by e to the power x divided by 2. Okay, this is our inverse function of this one, and we need to find the value of the limit. We have already find it. Then objective is remain 1. Let's multiply upper limit of the function first integral to lower upper limit of the second. That will be equal to 3 times log 19 minus lower limit of the first integral to lower limit of second, log that will equal to log 5. Let us simplify this one, and I hope you can do this at one level. That will be equal to log 19 to the power 3 divided by 5. The option A will be correct. So now you can see this property is very useful to solve definite integrations problem, which it might be difficult to solve in other approach. Okay, so this is all about this property. Try to solve some questions from your levels, and thanks for watching. Have a nice day. Bye bye.